In the previous lecture, we looked at some examples of how to take a number in a base other than 10, a non-decimal number, and convert it to the equivalent decimal value. All right, in this lecture, we're going to go the other way. I have a base 10 number here, 1,398, and I want to convert it to the equivalent base 5 number. Now, there are two ways of doing this. I have a personal preference, and I'm not going to tell you which one it is because I don't want to bias your choice, right? You need to look at the two methods, try them out, do some practice problems, see which one feels best to you, and then stick to that one. Because there really is no reason to prefer one of them over the other. Obviously, they're both correct. They both give you the same result. And computationally, I don't think one of them is really more complicated. So it really comes down to personal choice. All right, so the first method, I'm going to start by writing out powers of 5, because that's the base we're aiming for. So I'm going to give 5 to the 0 is 1, 5 to the first is 5, 5 squared is 25, 125, 625, 3125, and this is where I'm going to stop. 3125 is greater than the number I'm trying to convert. Right, once you pass that number, you've got all the powers you need. And I'm actually going to take this one out because we're not going to need it. Okay, so I've got 5 numbers on my list here, which tells me that my final answer is going to have 5 digits. So I'm going to put 5 lines here, one for each one. Okay, here comes the real procedure. We're going to start at the high end, right? So we're going to fill in the leftmost number first. I need to know how many 625s there are in 1,398. Well, that's a division problem. I'm going to do 1,398 divided by 625. That's 2 and some change. So there are 2 625s in 1,398 plus a little left over. Right, so let's put the 2 down here. And now I need to know how much is left over. So if I do 1,398 minus 2 times 625, there's 148 units, if you will, that I still have to figure out where to put in those remaining 4 spots. So now we're just going to do it again. I did the 625s, the 5 to the fourths. So now I'm going to do the 5 to the thirds. 148 divided by 125 is 1 plus a little. So there's 125. And what's left over? Well, 148 minus 1 times 125 is 23. Do it again. Now we're going to do the 25s. So if I do 23 divided by 25, this is a little different than what we've seen. It's 0 and some leftovers. And that's fine. There are no 25s in 23, so I'm just going to put a 0 for my next digit. Now you can do the arithmetic here for the 23 minus 0, but we didn't take anything out, right? So we're still looking at 23. And now we're going to do the 5s, right? So I'm going to do 23 divided by 5. That's 4.6. So there are 4 5s in 23. That goes in my second to the last spot. What's left? 23 minus 4 times 5 is 3. You can do one more line, do 3 divided by 1 if you really just want to complete the process. But once we get down to the last spot, that 3 is what's going to go in it. Now, we're not quite done. There's one more little detail here. And please, ladies and gentlemen, this is an important detail. Please do not leave this out. You got to put the little subscript down here, saying that this is now a base 5 number. Yes, I know students think I'm being wildly picky, but if you leave that out, the answer really is not 100% right. Okay, so there's my answer. 1398 base 10 is equivalent to 21043 base 5. There's a temptation to read that 21,043. It's really not a good idea. There aren't 20,000s. There aren't 410s for 40. It really isn't a base 10 number, so it's kind of a bad idea to try to use that base 10 terminology to read it. Okay, how about the second method? Second method is also all about division, but we're going to look at the remainders. So what I'm going to do is I'm going to do 1398 divided by 5. That gives me 279 with a remainder of 3. Now I'm just going to keep dividing by 5 over and over again. 279 divided by 5 is 55 with a remainder of 4. 55 divided by 5 is 11 with a remainder of 0. That's interesting because we had a 0 in our answer. This is the same number, by the way. I'm doing the same number with the other method, so you can see we get the same results. 11 divided by 5 is 2 with a remainder of 1. 2 divided by 5 is 0 with a remainder of 2. When you get to 0 remainder something, that's how you know you're done. All right, so this is where I've got all the numbers that I need to answer my question. Again, there's 5 rows here, so there's going to be 5 digits in my answer, just like it was before. Okay, so how do I get those digits? Look at the remainders. The remainders are the answer. I'm going to read the remainders from bottom to top and write them into the number from left to right in that order. So 21043 are the remainders. 21043 is my answer. Yeah, it came out to be the same thing, right? Same answer either way. Don't forget, you got to put that little base 5 down there. So now you've seen the two methods. As I said, I can't think of any reason, any technical reason to prefer one over the other. So you may have, if you've got some homework to look at, you can get a little practice and try using both methods. Just see which one works both best for you, and then kind of stick to that one. So in the next lecture, we got one more lecture to go in our discussion of different bases. We're going to take a look at how to do some basic arithmetic in different bases. We'll see how to do both addition and subtraction.